want to talk briefly about phase diagrams. So a phase diagram is where you're looking at pressure versus temperature for a particular substance. And we get these lines where the different phases can coexist. And these lines also tell us how we can transition from one phase of matter to another. And typically, when we talk about phase transitions, as we did in this particular chapter, or was it last chapter? Physics 101 and Physics 251 teach the same information in a slightly different order. Anyways, we talk solely about temperature, where you have to go from a solid to a liquid. You first have to raise the substance up to the melting point, then the energy goes into the phase change, where you get these specific temperatures where a phase transition can occur. And that's because we are discussing the Earth's atmosphere, where we're constantly underneath atmospheric pressure. So approximately 1 atmosphere, or 1.013 times 10 to the 5 pascals. However, if we're not under the same pressure anymore, pressure and temperature both play a role in where a phase transition occurs. And you'll notice very clearly here with solid and gas, there is a very wide range where you can skip the liquid phase. So if you're at low pressures, you can go from a solid to a gas and completely skip the liquid phase. And in fact, this is the issue on Mars right now, where the atmospheric pressure is about 1% of Earth's atmospheric pressure. That means that the pressure is incredibly low, so as you raise the temperature, you don't get liquid. You go from a solid to a gas. So you can actually get water to boil and thus vaporize at those very, very low pressures, temperature pairs. So you can get water to boil at room temperature when we're used to it having to boil at 100 degrees Celsius. This is an issue when you go to higher elevations where the atmosphere is distinctly a lower percentage of what you get at sea level, where they actually have to have different cooking directions because the water boils at a lower temperature, so you're not getting the energy into the food that you normally would, and therefore it cooks differently.